I'm definitely reaching a point where my brain is starting to turn into mush when it relates to how to measure these very tiny things. My research shows that an electron is really difficult to measure. So let's back up a little bit and measure what's called a mass to charge ratio of atoms. Okay, if we can do atoms, then maybe we can get this other stuff going on. In order to measure the atoms, we have to all agree that there are electrons. Okay, electron is a particle. We're just going to have to accept that electron is a particle. We don't really know what it's look like. Is it round, square, wave? Who knows what it is? At this point, that's all I can say. And that every atom has a number of electrons that keep it neutral in terms of charge. So, if we can create an ion out of one of these atoms, it becomes charged particle, and we can accelerate it with plates. In this case, it's going to be going from a positive plate to a negative plate, so that the ion is attracted towards the negative plate, goes through a slit, and then a magnet deflects that beam down to a detector. I've got a image coming up that looks halfway decent that we can look at. But we're talking about trying to measure the mass of an atom. And we'll first go through the picture of the machine, which, if you actually go to look at one of these machines, all you see is this giant setup with wires and stuff coming out. It's hard to figure out how the thing is supposed to work. But anyway, the diagram, I think, will give you a pretty good idea of how this mass spectrometer works. Remember where we're going. What we wanted to do was find out about this darn electron thing. But in order to get there, let's first look at a modern mass spectrometer, not the actual picture of the mass spectrometer, but a diagram of what's going on inside the mass spectrometer. And then maybe we can get a better idea of how that is used to come up with mass. Okay, here's the diagram. Here's the sample they talk about molecules here, but they could be atoms. You've got a sample here that you have to heat up to where it's in the gaseous form. If we don't have atoms in the gaseous form, they're going to all stick together and they won't go anywhere under the charge. Then we have a positive repeller plate that will, if they're positively charged, that they're going to be repelled by this plate. And then we have a negative filament that has electron beam that will knock electrons out of the sample. We want to knock electrons out of the sample so that it turns positive ion, and then it is accelerated towards these negatively charged plates. And you can see this has to be done under a vacuum. If it's not done under a vacuum, then we're getting air molecules and trying to ionize all that kind of stuff, which doesn't make any sense. So the vacuum, under high vacuum, then this beam is accelerated, and it just shows a simple bar magnet. Actually, in the device, it's probably going to be some kind of superconducting magnet so that we get a good, strong magnetic field. Then you can see that the beam is spread out across the detector. those items that are more massive will be deflected less. Those that are less massive will be deflected more. Goes down to some kind of collector. And then here's where you have a computer that analyzes all the detector items, and then it gives you a spiked graph. I hope this helps. It might even confuse you more. I'm not sure, but I hope that this kind of gives you an idea of what's going on. And then once we start looking at these different uh, deflections of the atom, then let's see if we can come up with some math and actually relate this to some numbers. If we don't have numbers, then we're not measuring the mass. We're just kind of playing around and deflecting ions, which won't give us the information that we want.